Okay, so it was great. What I'm aim to present is a model that we are developing here in Umeå University, and this model represents a district, or more precise, Ålidhem district in Umeå city. You can see it here. For those who don't know, Umeå is, maybe I can have a pointer here. Yeah, so Umeå is located the east coast of Sweden, and then this district is just one of the districts in the city. So this district is about 160 apartment buildings. There's student dormitories, rental apartments, and some private owners as well. There are some service buildings as commercial center and education building, but they are still not part of this model. We are still fine-tuning some of the figures in the model, but I will show some result anyway. And the district is connected to all the buildings in the district are connected to the district heating, which is the main source of heating for this district. Yeah, within the district, there have been already some refurbishment of building, about 21 buildings ended in 2015. There was two types of refurbishment. 20 buildings went through, I can call it essential refurbishment, which is replacement of the windows. So those buildings in the district, most of them were built in the 70s. So they are more than 50 years old. So some parts of the building are now in a need for refurbishment. So, for example, windows, replacement of water and electric appliances, and also improve insulation. So that was done in 20 of the buildings. I call it essential because this is the time to do it. And it should be done, for the rest of the building as well, such measures. But one of the building also had the necessary refurbishment, but also as a pilot went through a more intensive refurbishment, which include wall insulation and adding recovery in the ventilation and improve air tightness. This is more advanced refurbishment, which is at higher cost, but can prolong the lifetime or the economical lifetime of the building, and therefore should also become considered for the other business as well. So the model, the first stage of the model is to kind of look at the energy flow within the district, where the energy comes and where it goes. So if you look at the right side of this flow chart, Gantt chart, here we can see the energy services of the building in terms of energy content. So most of the energy is actually going to the building as heat. There's a lot of demand for heat and electricity as well. And then we have some losses from the production, energy production. And we have also transport, energy for transport, which is the smallest part of the energy flows. If we go back to in the energy change all the way to energy resources, we can see on the left side that the highest energy resources is actually biomass, come from the forest as biomass production, but we also have municipal solid waste to produce both heat and electricity. And then we have included the electricity production, the Swedish electricity production, which is nuclear, hydro, wind, solar, a bit of solar, and some other type of fuels. And of course, on the bottom side of the picture, we can see the fuels for transportation that is used in this district. So this is kind of energy flow just for the specific district. So in total, we have annual emissions from the district about 5 tons of CO2, a bit over 5 tons of CO2. Most of the emissions come from burning municipal waste, about 3,000. And the second for transportation, burning fuels for transportation. And the next one is biomass production and electricity production, or biomass, burning biomass and electricity. Here in Sweden, we consider our forest as sustainable, and therefore we don't include the emissions for burning biomass, because we are saying it's going back to the forest. So there's a kind of a cycle. So the emission for biomass is very low. So the highest cost is municipal waste, followed by transport in that case, in this district, specific district. So our idea is to get to kind of a zero emissions is to ask ourselves, how can we compensate those over 5,000 tons of CO2? What kind of emission or measure we can do in the district itself in order to reduce the same amount of CO2 emission equivalent? And then can we say that this is a zero emission district in that case? So we look at different measures, but we look at the entire energy change. That means that if we reduce municipal waste, burning municipal waste, we ask the question, what happens to the municipal waste that we are saving? And our answer to that is that this municipal waste will be sold to some other part of the world and will be replacing some other fuels, for example, coal. And by that, we can calculate the avoidance of emissions for burning coal. So this is our methodology in this model. So with the time I'm left with, I want to show you one scenario. How can we compensate those 5,200 tons of emissions for this specific district? And in that scenario, what we have, there's 4 different measures. The first measure is the refurbishment of the building we're saying that all the building in the next until 2040 will go through this essential refurbishment, which is kind of needed for those buildings. So this is the first measure in this scenario. The second measure is the transportation will move into electric cars. And here we use kind of an average development over Sweden. And that could be questioned if this is relevant to the district, or in the district it could be higher or lower than the average value over Sweden. And then we also use a measure in the production itself, in which we say that some of the municipality waste will be replaced by biomass, in a way that even if we do energy efficiency measures on the building and reduce the energy in the building, we still in the production, we use the same amount of virgin wood from the forest, and the impact would be mostly on the municipal waste. That means this is kind of a recycling. We increase recycling in the city, so we have less waste coming into the district heating plant. So this is a recycling measure. After doing those 3 type of measures, the third measure is to install PVs as extra production of green energy. And in this case, to reduce to come to zero emissions, we need to, by 2040, get about 20,000 square meters on the roof of the building, which is quite a lot. And then we can discuss if maybe to install less PVs, maybe we can have more advanced refurbishment in the building instead of just the essential, or we can encourage people to move from cars into other type of transportation, like bicycles and public transportation, or we can replace more municipal waste by biomass, or by increasing recycling in the district itself. So this is one type of a scenario. This is what we can do with the model, and try different type of solution and see what is the measure that lead us to compensate the emissions that currently are generated by specific district. Yeah.